guys. Today we're here to talk about the TEAC 85D, which is basically states that you need to be able to recognize that chemical formulas are used to identify substances, and you need to be able to determine the number of atoms of each element in a chemical formula. So let's take a quick look at a chemical formula. Right here I have calcium chloride, CaCl2, and the things I noticed first off is that the capital letters are going to represent new elements. Elements are the letters on the periodic table. So a capital letter followed by a lowercase letter would be one element. And here there's a Cl, same thing. This is another element. So if I find those on the periodic table and looking them up real quick, I can determine that Ca is for calcium and that Cl is for chlorine. Okay? So remember, if the element symbol is a capital letter followed by a lowercase letter like these, that is still the same element. So every capital letter in a chemical formula represents a new element. So I know now that this is calcium because we just looked it up. And this was chlorine. So how many elements make up calcium chloride? Because that's the name of this compound. How many elements make up calcium chloride? If you said 2, you're absolutely right? Calcium and chlorine. So the elements, remember, once again, the elements are the letters. Now we also have this little number. The little number is called a subscript. So what if I wanted to know, since I already know now calcium chloride is made of calcium and made up of chlorine, how many atoms of calcium are present in one molecule of calcium chloride? Well, Ca represents calcium. It's only in the formula, or only listed in the formula once. So that means we only have one atom of calcium. What about chlorine? Well, chlorine is followed by the 2. So chlorine has not just one, because it would only be the symbol if it had just one atom. There are 2, and that's what the little subscript tells us about chlorine. There are 2 atoms. All right, so let's look at a couple other examples of this. So here you have the formula for glucose, C6H12O6. So how many elements are in glucose? How many elements? Well, once again, the periodic table of elements tells you those are the letters. Every capital letter represents a new element. So there are 3 elements. There is carbon, right? And oxygen. But how many carbon atoms are there? Well, the little subscript says there's 6. So you'd have to have 6 carbon atoms to represent how many carbon there would be in this formula. You need how many hydrogen? Woo-wee. 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 hydrogen atoms. And how many oxygen? 6. So, this compound, C6H12O6, known as glucose, contains 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. But it only contains 1, 2, 3 different elements. let's try another one. How about this? This is ozone. This is the chemical formula for ozone. How many elements are present? There's only one element present, and that is oxygen, right? How many atoms of oxygen are present? 3. So that was your ozone. Okay, good job, guys. Let's try another one. How about this one? CuSO4.
Stephanie Stayhaw, please come to the front office. Stephanie Stayhaw, please come to the front office.
Copper sulfate. How many elements? Elements, periodic table of elements. So how many elements are there? Well, I see a C followed by a lowercase letter. I see Cu. That must be one element because every element starts with a capital letter, so that must be 1. Then we have a capital letter and a capital letter. There are 3 elements in copper sulfate. And if we look here, I was right. The Cu on the periodic table is 1 element. It is copper. Okay? How many atoms of copper do we have? Well, it's only listed once, so we have 1 atom of copper, right? How many sulfur atoms do we have? Well, there's only 1, so we only have 1. What about oxygen? How many oxygen atoms are there? Yes, you said it right. If there's a subscript of 4, oxygen would have 4. Sometimes in rare circumstances, you will see that there are formulas with parentheses, and outside their parentheses, there's an additional subscript. So I'm just going to make something up just for the makeup sake so we can look at one. Let's say we have CaOH3. Let's make that a 2 just for the sake of seeing what happens. So we have calcium, oxygen, and hydrogen in the formula. We have 1 atom of calcium. But here, inside parentheses, we have O2. We could even do O2H2 and a 3 outside the parentheses. It's just similar to math. When you have something outside the parentheses, you are going to multiply it by what's inside. So they're not added on. These are multiplied, okay? So oxygen was initially 2, but multiplied by the 3, 2 times 3 becomes 6. So there's 6 atoms of oxygen. And hydrogen was initially 2, but also multiplied times the 3, which is outside. That gives us 6. So then we would have 1 atom of carbon, 6 atoms of oxygen, and 6 atoms of hydrogen in this example. All right, I think that pretty much does it for now. I hope that this helps you get through the activities and that you are successful on STAR this year. Thanks for watching.